Hello students, the next topic is systems of equations. This is partly a review from linear algebra, a review from intermediate algebra, and partly a preparation of some modeling problem from section 1.7 or some other sections from other chapters as well. In short, this is a kind of tweener between linear algebra, I keep saying linear algebra, between intermediate algebra and college algebra. Here's a motivational problem. Consider the system of linear equations, 2x plus 3y equals to 6, and x plus 4y equals to -1. We have two equations and two unknown variables to determine, so it looks good. We can do it. But the problem is, do you all remember how to do it? In case you don't, well, that's why we are doing this, as a review. The first method here is a method of substitution. Basically, what we do is select one variable from any equation here, solve it, and then substitute it into the other equation, solve the other variable, and then substitute it to, well, you see the picture, a lot of substitutions. Okay, let's go. Let's make the initial selection. Which variable do you want to solve for? In my opinion, this is the best choice. Why? That's because it's standing alone. If I select, for example, this 3y, in the end, I have to divide by 3. If I select this 4y, I have to divide by 4 in the end. Same problem here. If I select this 2x, I have to divide by 2 in the end. For this one, I don't have any division to worry about. Here we go. We got it. We got it solved. So what do we do now? Substitute it into the other equation. If you plug it back into this, then you're going to get -1 equals to -1. That's too trivial. It didn't really tell you anything. You have to put it into this. 2x plus 3y equals to 6, all right? But in place of this x, substitute -4y minus 1. That's why this method is called the method of substitution, because we have to do substitution. Break up the parentheses, -8y minus 2 plus 3y equals to 6. Now take the like terms together. I hope my computation is correct. Let's see, please check. As a matter of fact, let's check it this way. Okay, all good. Okay, all good. Alright, now that I got y equals to -8/5, let's plug it into any equation here as long as there are both x and y. The first equation here is good. Second equation there, equally as good. But in my opinion, this one is the best. It's already solved in terms of x, so just plug it in here. X is equal to -4y minus 1, but in place of this y, I have -8/5. Okay, let's do this computation. You can use your calculator if you want to. -4 times -8, positive 32, and then minus 1. Minus 1 is equivalent to subtracting 5/5. So 32 minus 5, that's 27. Okay, here we go. X is that. Therefore, the solution is 27/5, -8/5. Let's check. Yes, all correct. So after getting the answer here, substitute it to any equation, either the first equation or second equation or any equation that appeared, as long as they are both x and y in there. This one turned out to be the best because it is already solved in terms of x. This kind of method is called the method of substitution because we have to do some substitutions here, twice to be a bit more precise. Let's go to an exercise problem. Do you recognize this problem is essentially the same as before? We have a standalone variable y here, so you can solve for y and then substitute it into y from the other equation here. And then you're going to get an equation of x alone. Solve it, get the value, and then plug that in, substitute into any of the equation, and so on and so forth. Essentially the same. So let's do a little bit harder problem here. This time I don't have anything standing alone, so let's select the second best. I don't have lone x or lone y, so the simplest, let's select this 2y. In the end, I'll have to divide by 2, but that's better than dividing by 4 or dividing by 3. This would have been equally as good, but, well, from the first equation, that thing showed up, so let's go from there. So negative 3x plus 2y equals negative 1. So flip this negative 3x to the other side. 2y equals 3x minus 1. Y is 3x minus 1 divided by 2. Okay, that looks good. So we have y equal to something, alright. So let's substitute this one into any of the equation here, but this is a bad idea because we already used up. So if you do that, you're going to get negative 1 equals to negative 1. It doesn't help you anything. Let's go to the other equation and substitute it over here. If you do that, you're going to get 2x plus 4y equals 3, but here, in place of 4y, in place of this y, you're substituting in this 3x minus 1 over 2. Okay, we have the resulting equation and we have only one variable to solve for, so we can do it. The standard process. Denominator, parentheses, and the like terms. Denominator first. 4 divided by 2 is 2, so we have 2x plus 2, 3x minus 1 equals 3. And then break up the parentheses. Did I do this right? Please check my computation. Stop the playback if necessary. Okay, I have the solution here. One of the two solutions, of course. Is everything correct? I'm not so sure, so let's check. Oh, I don't have solution here. So the answer is supposed to be 5/8, 7/16. We have 5/8, so far so good. So far so good. Okay, let's continue. Let's substitute this 5/8 into anywhere. I can put it into the first equation or second equation, but in my opinion, this is the best. Any equation will do as long as it has both x and y in there, but this one is solved already in terms of y, so let's do it this way. 3x minus 1 over 2. And then let's substitute it. In place of this x here, substitute 5/8 in there. It's difficult to read, so let me expand the font a little bit. Okay, we got the substitution here, and let's simplify as much as possible. Multiplying 8 to each term here, you can multiply the same thing to both numerator and denominator, and my strategic selection here is 8, so that I can remove this denominator. If I do that, that's gone, so we have 3 times 5, so this whole thing is going to become 15. Multiply by 8, 1 times 8 is 8. Multiply by 8, 2 times 8 is 16. And we have, as expected, we have 7/16. Therefore, the solution is we already checked. The answer is supposed to be 5/8, 7/16, and then we have everything here. Okay, do we have time for another problem? I don't know. Let's try. I may have to stop halfway through. How about the next problem here? We have some decimals. So my first reaction here, my initial reaction, is to remove the decimals. Multiplying 100 to each term in the first equation, I can remove this decimal because we have only 2 decimal digits. So multiply 100, 2 more 0, multiply 100, multiply 100. There you go. So here's my system. And from here, let's solve for x. And then substitute it to the other equation. So 1000 minus 2y. Let's put some more space in between. And then substitute this one into x from the other equation. So 70x plus 15y equals to 24,000. But in place of this x, we have 1000 minus 2y. We can solve it and then get the y value and substitute it into anything actually. Probably this one. Okay, let's do as much as possible. 70,000 minus 140y plus 15y is equal to 24,000. Take the like terms together. Negative 140 plus 15, so minus 125y equals to 24,000 minus 70,000. It's going to be negative 46. So y is 46,000 over 125. Let's use calculator. What do you get? 368. Are we supposed to have 368? Okay, y is supposed to be 368, so it looks like everything is good. And substituting everything into this equation, we will be able to find that x value as well. So this one is going to be 368. And then let Mathematica calculate this thing. You can use handheld calculator too because it's simple computation. I'm getting 264. Did I get? Yes, okay. Looks good. So 264, 368. And there goes the full solution. Did I move too quickly? Then stop the playback and read through. Okay, looks like this section is completely done. Let's meet again in section 2.